Hello everyone, and let's have a look at this example. Okay, so this example, they say a 70-kilogram skateboarder moves down a slope while experiencing a frictional force of 119 newtons. The slope forms an angle of 30 degrees with the horizontal. At some point A on the slope, the skateboarder is moving at 6 meters per second. 10 meters after point A, he reaches the bottom of the slope, which is point B. Question A. Calculate the gravitational potential energy of the skateboarder at point A. And then B. Calculate the speed of the skateboarder at point B. Alright, so let's see what we have here. So we know that what do we have in this question? Right? What do we know? Okay, let's write down what do we know right here. Right? Let's write down what do we know right here. Okay? We know the mass of the skateboarder, they said, was 70 kilograms. We know the value of the frictional force, it was 190 newtons. Okay, what do we know? We also know theta, 30 degrees. We also know that the skateboarder is moving. At some point A on the slope, the skateboarder is moving at 6 meters per second. So I'm going to take that as my VI. At some point I'm just going to note it as VA, 6 meters per second. What else do I know? Delta X, that I'm working with, is 10 meters. And then he reaches the bottom of the slope, point B. So I can draw my slope. Okay, so there's point B at the bottom there. And here we go. Here's theta over there. 30 degrees. Let's say A is over here. Alright, and we say that that is 10 meters. Okay, perfect. Now, that's all I know. And I know the formula for this is, if I just write example here. Example, alright. Then all we do, WNC is equal to the change in EK, alright, plus the change in EP. Alright, cool. So what I'm going to do is I'm going to allow you to attempt this question on your own, and then return to the video and check out the solutions. Alright, go ahead and attempt the question. Okay, so let's have a look at question A, where they asked us to calculate the height, alright, of the skateboarder at point A. Well, what do we know so far about the question? We know that the angle theta was 30 degrees. Alright, we also know the mass of the skateboarder. Alright, we also know the distance between A and B, alright, which is 10 meters. Alright, so in order for us to calculate the gravitational potential energy of the skateboarder at point A, we first need to calculate the height. Okay, mgh. Alright, and this is how we do it. So we can see here that this is h, and all we need to do now is, because we have our angle and we have our hypotenuse, alright, we know that h will be equal to, alright, 10 sine 30 degrees. Alright, and how do we get that? So I'll just put a side note up top here, okay, is that sine 30 degrees, alright, is going to equal opposite, which is 8, over our hypotenuse, which is 10. Alright, so if I multiply that side by 10, and this side by 10, and the other side by 10, I end up with 10 sine theta equaling h, which I have over here as well. Okay, and if you punch that in on your calculator, you will find that therefore h equals 5 meters. So therefore h equals 5. Alright, so now we can go calculate EP. All right, EP is our potential energy. EP equals mgh. All right, now mgh, we know that m is 70 kilograms. And we're going to multiply that by 9,8, which is gravity, and we're going to multiply that by our 5 meters. And therefore, at point A, EPA, the gravitational potential energy of the skateboarder is 3,430 joules. All right, quite a lot of energy up there. All right, now let's go have a look at the second question. Second question asks us to calculate the speed of the skateboarder at point B, so when he has reached the bottom of the slope. All right, so what I'm going to do, Alright, so B. Now this is where this formula is going to come into play over here. Okay, since we have worked out what EP is, alright, so we know EP of A. Alright, now we just need to calculate what is the final velocity. Alright, so we know that if we expand this formula, we know that W and C will equal EKF minus EKI. Alright, plus, I'm just going to put this in brackets so we avoid confusion, EPF, alright, minus EPI. Alright, so we know that we're looking for EKF, we're looking for the speed of the skateboarder at the bottom of the hill, but we know that at the bottom of the hill at point B there's no potential energy, so that is 0. Okay, so therefore our formula will be the work of the non-conservative force is equal to half m, no, let's make that m a little better there. Alright, half mvf squared, alright, minus half mvi squared, because we do have a vi, alright, and we're going to plus mgh, alright, which is mgh of A. So we know the work of a non-conservative force, alright, they told us in the question that while he was moving down the slope, the skateboarder, he was experiencing a frictional force of 119 newtons. Alright, so while he was moving down, friction was going up, therefore the angle theta is negative 180, so cos 180 is negative 1. So I'm going to simplify and say negative F, force of friction, delta X, alright, which is what I would have got, alright, is equal to this whole equation over here. I'm just going to insert that here. Now I'm going to sub in, okay, so negative 190 times 10, that is equal to half of my mass, which is 70. Vf squared is my unknown, minus half m, which is 70, alright, half of 70, alright, times 6 squared, alright, then I'm going to plus, well, I made a mistake there, it's supposed to be plus negative mgh, okay, so I'm just going to put a negative above there, right here, plus negative mgh, so I'm going to plus negative 3,430, because we already know what mgh is equal to. Alright, so on my left hand side I get negative 1,900 is equal to 35 Vf squared, alright, minus, alright, I'm doing this live right now, I'm punching this into my calculator as I'm speaking, alright, so 35 times 36 is minus 1,260, alright, minus 3,430. Alright, so if we put all the minuses over onto the left hand side, so we will have negative 1,900 plus 1,260 plus 3,430 gives us 35 Vf squared. Alright, if we punch this side into our calculator, right, the side into our calculator because it's a straightforward function, okay, we can also divide this side by 35 at the same time, okay, which I will do. So I'll divide by 35 there, and I'll divide by 35 here. So negative 1,900, alright, plus 1,260, plus 3,430, alright, and we're going to divide that by 35. Alright, we get an answer of VF squared, alright, is equal to 79,714. Alright, and we need to square root this side. Alright, square root the other side. And I'm going to write it over here because I've run out of space. Therefore, VF, alright, final velocity at point B, alright, of the skateboarder is equal to, alright, 8,93 meters per second, and we can say at point B. Alright, and that looks about right since his initial velocity, alright, past point A was 6 meters per second, and at point B at the bottom of the hill, definitely that seems about right at 8,93 meters per second. Okay, and that was a question. Thank you very much.